Hello everyone, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today, we will be learning chords rules in DBMS. So you will find it is generally said as chords 12 rules. However, there are 13 rules. So Edgar F. Chord developed these chord rules in 1985 against his name. And the rules are 13, that is starting from 0 to 12, but normally they are said as chords 12 rules. So these rules are generally used to define the database, and after defining the database, it is used to check the quality of the database. So the rule 0 says the foundation rule. The foundation rule defines the system to qualify as an RDBMS. It must be able to handle the database entirely through the relational capabilities. This is the foundation rule. Let us go to the rule 1, that is the information rule. The information rule says that everything in a database must be stored in a table format. That means in the format of rows and columns. So for example, I have a table student which has attributes roll number, student name, branch and city. So in this columns, the data should be represented. So here this table will have these as columns, that is roll number, student name, branch, city as the columns. These are the rows, and one particular cross section or intersection of column and row is called as a cell. So everything in the data must be stored in the table format. So this is the information rule. The second rule is the guaranteed access rule. What do we understand by this? So this rules refers to the primary keys. As we have seen these primary keys in the earlier lectures, primary keys are nothing but they are used to uniquely identify a record in the database. So every single data element is guaranteed to be accessible via these three things, that is the table name, primary key and attribute name. So if I consider the table student, now if I want to access a particular record, what I have to do is I have to access with three things, that is the table name, primary key and the attribute key. So what is the name of the table? Name of the table is student. Primary key over here is roll number. So I have used this roll number as well, and the attribute names. Now here the other attributes are student name, branch and city. You can use any one of them or you can use combinations of them. So by using this statement, we can access the records. Then the next one is the rule number 3 is systematic treatment of null values. Now, if any of the cell value is unknown or not applicable or missing, it cannot be represented as 0 or empty. As we have seen in the earlier classes, not a single cell value should be empty or missing, or it should be empty. So it will if it is like that, if it is 0 or if it is empty, we have to represent it in some other format, and it is always represented as null. This null should be acting irrespective of the data type, which means that even if the data is int, character, varchar, anything, the null should go and fit into that cell. So here this is the student table. Now this particular cell did not have any value. It was, let's say the value was missing. So we cannot keep it as blank or empty. We just filled in with the null value. So this is the third rule. Then the fourth rule is active online catalog based on the relational model. Now what do you mean by that? So we have studied about the data dictionary. Data dictionary is the one which stores the metadata, and metadata is data about data. So this rule deals with data dictionary. Here in data dictionary, metadata is maintained for all the data in the databases. Now this metadata should also be stored as tables, rows and columns, and obviously it should be given some access privileges. That means authentication or access rights should be given. So this metadata which is stored in the data dictionary should also obey all the characteristics of the database. So it should have correct, up-to-date data. So even if it is a metadata, that means data about data, it should have up-to-date information about that data. Otherwise, inconsistency can generate. We should be able to access this metadata by using same query language that we use to access the database. So if we have seen in the earlier rule, we saw that if we want to access a record, we need a table name, we need a primary key, we need some attribute name. Obviously, in the similar manner, if we need to access the metadata as well, we need these three things. And these are happening in the query language. And the next rule is rule 5, the comprehensive data sublanguage rule. What do we understand by that? So any RDBMS database should not be directly accessed. It should always be accessed by some strong query language. So here the system must support at least one relational language that supports this DML, DDL, DCL and TCL. DML is data manipulation language, data definition language, data control language, transaction control language. So it has certain commands into it such as select, insert, update, delete, create, drop, truncate, grant, revoke. So the particular query language should have all these commands into it, or we can say all these commands should be there into this query language to access a particular database. So example of this is a SQL. There are many more. Now rule number 6, the view updating rule. Now views are the virtual tables created by using queries. Now for different users, different views can be created. So it can be the entire view of the table, or it can be the partial view of the table that can be shown to the user. We can say the views are the subset of the table. So obviously this partial table or the views will also have rows and columns, right? So this rule states different views created for different purposes should be automatically updated by the system itself. So if you are creating some subsets of the tables, or we can say views of the tables, it should be updated immediately. The rule number 7 says relational level operation. What do we understand by relational level operation? So the rule states that every query language used by the database should support insert, delete, update on the records. Obviously, it should give some support, some set operations as well, such as union, intersection, difference, union all. So all these set operations should also be supported by that query language. Then all these operations should not be restricted to a single table or a row at a time. It should be able to handle multiple tables and rows in its operation. So not only a single row is targeted, these all operations should be performed on the entire table. So that is rule 7. Rule 8 is physical data independence. We have seen that in the earlier classes. So what does physical data independence mean? So any change in the physical location of the table should not reflect the change at the application level. So best example is that, so whenever a physical schema is updated, it should not alter the logical schema, the next higher level schema. So here what we are doing is we are changing the location of the data from one place to another place. That means we are changing the physical schema, but this should not, or this should not alter the logical schema. That means the logical structure or the table structure of the data should not be hampered. So this is physical data independence, rule number 8. Let us go to the next rule, that is rule number 9, which is logical data independence. Now here, if there are any changes that are done to the logical structure of the database table, the user's view of the data should not be changed. So again, let us look with one example. So the logical schema, if it is modified, which is the next higher level of logical schema, it is the view schema. So it should not be hampered by this. So if I'm making changes to the logical schema, view schema should not be hampered. So the example is that there is one table, ID and name. Now I am updating it by adding one more field to it. So I am changing the logical schema, but this does not hamper the view schema. So this is logical data independence. Let us go to the rule 10, which is integrity independence. Now this integrity independence means database should be able to apply integrity rules by using its query language. So there are certain constraints that needs to be applied to to the database, and that we can perform by using this query languages. So it should not be dependent on any external factor or application to maintain the integrity. So we have seen earlier many integrity constraints that are there, such as entity constraint, referential integrity constraint, check integrity constraint, domain integrity, default constraint, key constraint. So based on these, the integrity constraints will be applied to the database by using the query languages. The rule number 11 is distribution independence. Now, the database can be located at the user server or at any other network. The end user should not be able to know about the database server. So, the end user should not know where actually I'm accessing the data from. So, the user should be able to get the records as if he is pulling the records locally. That means there should be abstraction of the complexity, and I should think that, or the user should think that I am receiving the data from the machine that I am logged into. But actually, it is not the case. The data has been placed somewhere in the at different geographical location, and from there we are fetching that particular record. But we are understanding, or the user is understanding, that I am fetching the record from the system that I am logged in. So even if the database is located in the different servers, the accessibility time should be comparatively less. So even if the geographical different locations are different, it should not take much time to access the data. And this rule laid the foundation for the distributed database. And the last rule is the non-subversion rule, that is rule number 12. What do we understand by that? So obviously when a query is fired in the database, it will be converted into low-level language. So anything that is there into the computer, it is always converted into the form of zeros and one, and then only the computer can interpret it. So the query is first converted to the low-level language so that it can be understood by the system or the computer, and based on that, it should retrieve the data from the database. Now, in such a case, when accessing or manipulating the records at low-level language, there should not be any loopholes that alter the integrity of the database. So, in other words, even though the query written does not change the integrity of the table, the converted low-level language should be same as the query written. So there should not be difference between the query what is written and the converted low-level language. Otherwise, there can be integrity issues. So example of this is, so whenever I'm updating the student's address, query should always be converted into the low-level language first, which updates the address record in the student file in the memory. Now, it should not be updating any other record in the file, nor insert some malicious record into the file. So that is the non-subversion rule. So when I'm trying to update the address, so that query will be first converted into low-level language. It should update that record, only that particular student's car record, but it should not update any other record in the file, or nor it should insert some malicious record into the file. So that's it about the rules called 12 rules. Thank you for watching the video. If you have any doubts, please do comment in the comment box. Please like, share and subscribe to the channel. Thank you for watching the video.